Welcome dear learners, welcome in this module on dissolution, permeability and BCS. As you know, in the previous module we discussed about the chemical reactions and the racemization. Let me ask Jenny what she has done. Jenny, have you covered those things which I have told you? Have you done that homework?
Yes, I had done the homework.
Good. Have you learned some examples? New examples?
Yes, I had learned some new examples.
Perfect, perfect. Try to learn more and more examples, and dear learners also, you please learn more and more examples, then and then, only then you will explore the things, you will understand the things in better way. As far as the learning outcome is concerned of this module, after learning this module you will able to understand the concept of dissolution and theories of dissolution, factors affecting dissolution, permeability study and basis of biopharmaceutical classification system, that is BCS, and its importance. As far as the lesson plan is concerned, it will go like dissolution, its goals, basic concepts and theories, dissolution apparatus. Thereafter we will be moving to the factors affecting dissolution, then permeability, its concept, determining permeability with the help of diffusion cells, BCS, its concept, class of drugs and examples, and then application of BCS. Dear learners, let me explain you what is dissolution. Dissolution is defined as the process by which a known amount of drug substance goes into the solution per unit of time under standardized conditions. It is used for characterizing the biopharmaceutical quality of a product at different stages in its life cycle. It is used for choosing between different alternatives formulations for further development. Dissolution testing is an official test recommended by all pharmacopoeias, which are official books, for evaluating drug release of solid and semi-solid dosage forms. Now let me explain you what are the goals of dissolution, why it is important. Now why it is required, what is the goal of dissolution? Dissolution aims for the prediction of the in vivo performance. Actually we can have some ideas how the drug is going to behave in the actual biological system. With the help of dissolution we can predict that thing. We can use it for assessing the lot to lot quality of the drug product or batch to batch consistency. Say for example, we have produced a lot of 50,000 tablets and then second lot is also there of 50,000 tablets. How will you come to know that both the batches are similar in performance? With the help of dissolution we can predict that they are same in quality. Okay, so dissolution is a quality control test basically. It is used to guide the development of the new formulation, to ascertain the need for in vivo comparative bioavailability and bioequivalence studies. It is a mandatory requirement for regulatory approval. It is used to assess quality, stability or the expiration dates and optimization of the product. So dissolution is drug going into the solution, that media of GIT, simply it goes into the solution. This is called the dissolution. Now what is the basic concept? It is a two-step process. In the step 1, molecules are released from dosage form to media, creating a saturated layer or stagnant layer adjacent to the solid surface, and then in step 2 drug is diffused as per the concentration gradient from higher concentration to the lower concentration, and it can be expressed with the help of modified Noyes-Whitney equation, that is dx upon dt, that is the dissolution rate is equal to AdK upon H into Cs minus Xd upon V, where K is the oil and water partition coefficient. As far as the other parameters are concerned, the surface area of drug, it is governed by the particle size or the wettability. Surface area, we are talking about the active surface area, okay, which is actually involved in that process of diffusion or dissolution. As far as the physiological conditions are concerned, physiological properties are concerned, which are governing this factor are surfactants in gastric juice and biles. As far as the diffusion coefficient of the drug is concerned, it is governed by the molecule size and the viscosity of the luminal content, while the motility pattern and flow rate govern the stagnant layer thickness. That thickness is modulated as per the motility pattern. Okay. While the pH, buffer capacity, bile and food composition affect the saturation solubility, hydrophilicity, crystal structure and the solubilization affect the solubility. Permeability governs the amount of drug already dissolved, that is Xg, while the secretions and co-administered fluids affect the volume of solvent available, that is V. The dissolution can be explained with the help of some theories, the models. There are three major theories. First, diffusion layer model of film theory. Second is penetration or surface renewal theory, that is called Duncan-Watts model. Third is interfacial barrier model, which is called double barrier mechanism or limited solvation theory. In the very first theory, again two-step process, but a stagnant layer is formed around the drug particle. It is a rapid step. After that, drug is slowly diffused from high to lower concentration, and it is the slow or rate limiting step. So, in the diffusion layer model, the diffusion is the rate limiting step. Now, the second model, surface renewal model. In this, drug particle is continually exposed to the fresh dissolution medium. Numerous eddies or packets are there in the agitation medium. Okay. The solute diffuses into the packets and is carried to the bulk medium. Unlike the previous theory, there is no stagnant film layer is there due to turbulence or constant surface renewal, and that is why it is called surface renewal model. Okay. Now, the third theory is interfacial barrier model. In this model, it is also called limited solvation theory. A crystal undergoes dissolution through an interfacial process in the dissolving medium. The two surface area of the crystal must be considered. Each surface provides a different contribution to the dissolution process, and by this way the dissolution can be understood with the help of these three theories. And you can also learn the equation which express these theories or models. So, what we got here, that dissolution is a process which is used for various aspects of drug delivery, and it can be explained with the help of three major theories which must be understood with respect to the drug development. Okay. Now, let me clarify you how we perform these things. We perform the dissolution test in some apparatus. What is the nature of this apparatus? Let me explain you. In these apparatus are designed in such a way that we try to simulate the environment of gastrointestinal tract or that physiological condition. It contains a jar. Jar is hemispherical bottom. It is having. Why it is hemispherical? Because intestine is having hemispherical nature to mimic that physiology. Okay. Volume, we maintain the 900 to 1000 ml volume in the gastric environment, and that is simulated in this apparatus. We keep that media in the range of 900 to 1000 ml. Temperature we maintain at the just like as the body temperature, around 37 plus minus 1 degree Celsius, with the help of some heaters in that apparatus. We provide the agitation with the help of motor guided paddle or basket. Why? To mimic the gastric motility. What is gastric motility? With the help of gastric motility, the food content and the overall content move to the lower intestine, to the ultimately to the cecum or rectum. To mimic that motility, we give the agitation, and that is helpful for the drug dissolution or permeation. And these apparatus may be single station or multi station. Multi station means these there are 6 to 8 or more assemblies there put together in these multi-station assemblies and dissolution apparatus. These dissolution apparatus are standard. Standard means each and every specification is final. Say for example, in IP there are two official dissolution test apparatus. Paddle type apparatus is called type 1 apparatus and basket type apparatus is called type 2 apparatus. In those apparatus, each and every specification is unique. Now you have to learn, dear learners, do remember each and every specification of the length and dia of each and every part of this dissolution test apparatus. It is important with respect to your Viva Voce preparation, it is important with respect to your GPAT examination. Please do learn and try to draw this diagram at least 10 times, practice with each and every specifications. Okay. As far as the USB apparatus is concerned, USB prescribes 7 dissolution test apparatus. First two are the same, but here type 1 is rotating basket. Remember this thing always, it is always asked, it is a tricky question in some examination, that in USB type 1 apparatus is rotating basket, while IP type 1 apparatus is rotating paddle, and in the type 2 USB apparatus it is rotating paddle, and rest of the equipments are used only when these two, first basket or paddle, fails to perform this thing. With respect to the requirement of oral, immediate release or modified release products, we can use these 7 type of dissolution test apparatus, and you can go through the further links for getting more information about each and every dissolution test apparatus prescribed by the USB. So we perform dissolution in dissolution test apparatus which are official, and each and everything is standard. You know, the size, shape, length, dia of each and every part of the dissolution test apparatus is standard either in IP or in USB. You must learn these things, and this is helpful in having an idea about the drug release. So dissolution test apparatus is very important with respect to study of drug release. Okay. Now let me enter into the domain of the factors related to the dissolution apparatus. We have discussed the factors related to the dissolution test, overall dissolution. Now we are discussing the factors of dissolution apparatus. First is type of apparatus, second is dissolution medium, third is agitation, fourth is temperature. Type of apparatus we have discussed, there are so many type of apparatus. Depending upon a choice we can have the things, we can select the apparatus. Okay. As far as the medium is concerned, as we have discussed that we try to mimic, we try to simulate the environment, simulate the physiological condition with respect to the volume and pH, or maybe the presence or absence of some enzymes. We may try to have SIF, simulated intestinal fluid, we will keep the pH 6.8, SGF, simulated gastric fluid, we keep the pH 1.2, we use the phosphate buffer pH 6.8 and pH 1.2 acid buffer in case of SGF. We may add co-solvent or surfactant depending upon the requirement. It is not mandatory that we always try to mimic the media, nature of media. Sometimes we have the entirely different type of media just to have a similar kind of dissolution profile as that of the standard drug. When we are performing the bioequivalence studies, you will study it when we will be studying, when you will be studying somewhere in what is the bioequivalence, how the bioequivalence is performed. We try to have that dissolution profile, we try to have the similar dissolution profile, and for that we select a suitable kind of media. It may be completely different from the natural media present in biological system. Now what are the recommended medias? FIP recommends 4 major medias: 0.1 SCl, buffer solution pH 4.5, SIF, simulated intestinal fluid without pancreatine pH 7.5, and 0.05 m phosphate buffer solution of pH 5.8 to 8. Now dissolution, rapid dissolving. What do you call rapid dissolving? What kind of drug is called rapid dissolving? An immediate release drug is characterized as rapid dissolving when no less than 85% of the labeled amount of the drug substance dissolves within 30 minutes. choosing USP apparatus 1 at 100 rpm or USP apparatus 2 at 50 rpm in a volume of 900 ml or less of each of the recommended media. Whatever the recommended media, FIP recommends 4 dissolution media, which we have mentioned in the earlier slide. Now agitation, let me explain why we require the agitation. We have discussed that we want to mimic the gastric motility. Our gastrointestinal tract have the motility, it starts from the GIT, it's like this movement, okay, this kind of motility is there, okay. To mimic that motility, mild agitation conditions should be maintained in the dissolution testing, and it allows for the maximum discriminating power. Agitation is done to detect products with poor in vivo performance. Generally we keep the agitation 50, 75 or 100 rpm, and in general it is mentioned in each and every monograph in your pharmacopoeias that what kind of what would be the agitation speed for particular kind of dissolution test apparatus, and we can refer the official books pharmacopoeias for that agitation, okay. Now another fact, that temperature, obviously it should be at the body temperature plus minus 1 degree Celsius. Temperature of apparatus must be maintained before the beginning of test. You cannot do like that when you are starting, when you are putting your tablet into the dissolution test apparatus and you are starting your dissolution test apparatus. No, it is not like that. When you prepare the cake in your microwave, you preheat it, you have to maintain the temperature before beginning the process, okay. So before starting the test you have to maintain the temperature at 37 first, attain the temperature, then the apparatus will maintain that, okay. So what is the problem, that if you not maintain the temperature, increase or decrease in temperature may affect the solubility, it may increase or decrease the solubility as well as the dissolution. So overall dissolution test may get affected if there is increase or decrease in temperature. So what we got, that dissolution test apparatus are affected by their design, okay. What type of apparatus is there, number 1. Number 2, what kind of media you are using. Number 3, what kind of agitation you are providing or what kind of temperature, whether you are maintaining the temperature or not. These are the major factors which are associated with the dissolution test apparatus. Now let me enter into the domain of the permeability. Now we have covered the dissolution, now we are moving to the permeability. Drug slowly dissolves, goes into the solution, and thereafter it passes across the biological membrane, which is called permeability. Then and only then it gets absorbed. If a drug is found potent and active, but if it is not permeated, it won't be absorbed. So permeability is very vital, it is very critical, you cannot avoid. Without permeability, no absorption. So permeability can be predicted by the partition coefficient, which we have explained in our one of the modules which we discussed in the first week, that with the help of partition coefficient we can predict the permeability. It depends on chemical nature, molecular weight and microenvironment of the drug. A drug substance is considered highly permeable. Now what is highly permeable? When the extent of intestinal absorption is determined to be 85% or higher, it is called highly permeable. It means if the extent of absorption is 85% or more, then it is highly permeable. Permeability is assessed by, how will you determine permeability? We determine the permeability, like dissolution is determined by the dissolution test apparatus, permeability is determined by the in vitro diffusion cells or in vitro permeation apparatus they are called. So dear learners, let me give you the live demonstration of the in vitro diffusion cell. This is the in vitro diffusion cell. This is very small instrument, small apparatus which is made up of glass. As you can see, it contains two compartments. One is receptor compartment, which is bigger as compared to the donor compartment. You know, donor compartment is placed on the receptor compartments and it is clamped with the help of these two clamps. You know, You can see these are the clamp holders. With the help of them we can put them tightly closed. What happens that in between these two compartments we can place a semi permeable membrane, which may be natural intestine, natural skin, or the artificial membrane, which may be made of cellophane. As you can see, inside this receptor compartment is a internal compartment, which is actually the receptor compartment, which is filled with the PS 7.4 phosphate buffer as the receptor media. Generally the volume is pH, it may be 3.5 or 5 or maybe 12.5 depending upon the requirement. Okay, and you can see the outer jacket, it is there to water inlet, water outlet, for maintaining the temperature of this whole assembly at the body temperature. What we do, we put the drug into the donor compartment, pre-wet drug is loaded here, and that receptor compartment, on the receptor compartment we put this donor compartment, in between them that membrane is mounted, and then the pre-filled receptor compartment, which is always in touch with this cellophane membrane, what happens, that drug starts diffusing from donor compartment slowly to the receptor compartment, and for mimicking the agitation, what we do, we put a small bead inside the receptor compartment and put it in upon the magnetic stir. The agitation is given there with the help of that magnetic stir. That bead moves inside the receptor compartment and give the required agitation, and with the passage of time, this is the sampling port. We take out the sample 1 ml or 0.5 ml or lesser amount and replace the same amount of pre-warmed media into this receptor compartment, and by this way, by analyzing the samples, we can have the idea that with respect to time how much amount of drug is permeated across this membrane. So, this is the purpose of in vitro diffusion cell. So, dear learners, you have seen that this is a very small apparatus made up of glass, and remember, it is unofficial, it is not official in any pharmacopoeia. Design and fabrication differ from one model to another model depending upon the requirement or by the inventions made by some scientists. Like say for example, there are two cells, French diffusion cells and Kesri-Chain cells, KC cells you say. You can see and learn the design of these cells. These are called vertical diffusion cells. There are horizontal cells also. Please come back in the discussion forum with the name of the horizontal diffusion cells. Okay. So, we have learned that diffusion cells are required for the permeation studies. They give how the drug is permeating across the intestine or across the biological membrane. That permeation indication is given by the in vitro diffusion cell, as the dissolution gave the drug release profile. In the same way, in vitro diffusion cell gave the permeation profile. Okay. Let me explain you what is BCS. BCS, Biopharmaceutical Classification System. It is a drug development tool which was proposed by Amidon in 1995. Based on aqueous solubility and intestinal permeability, the drugs are classified into 4 major classes. What happens that the rate and extent of drug absorption from solid oral dosage forms depend on 3 things: dissolution, solubility and intestinal permeability. Depending upon solubility and permeability, Amidon 4-box model, it is called Amidon 4-box model. It is classified into 4 classes: class 1 high solubility high permeability, class 2 low solubility high permeability, class 3 high solubility low permeability, and class 4 low solubility low permeability drugs. Okay. You see that in US, if you go through, the top 200 marketed drugs in the US, BCS class 1 and class 2 are predominant. And if you see for the new chemical entities, the prevalence of low solubility drugs is as much as 70%. You know, BCS class 2 drugs are 70%. So this is why the importance of BCS is there, that we can have some idea that we can develop the drugs which are having good biopharmaceutical properties with respect to solubility and the permeability. Now, as far as the solubility is concerned, in the BCS, solubility is based on the highest dose strength in an immediate release product. Now, what is highly soluble? In BCS, what is highly soluble? A drug substance is considered highly soluble when the highest strength is soluble in 250 ml or less of aqueous media over the pH range of 1 to 6.8. Remember, it was the limit was pH 1 to 7.5 earlier. It has been reduced to pH 1.6.8, 1 to 6.8 in the recent guidelines. Now, moving to the permeability. Now, next thing is solubility we have got, but what is permeability? Based upon the directly on the extent of intestinal absorption in vivo in human, or indirectly you can have the data in vivo drug transfer across the human intestinal membrane as we performed in the diffusion cell. Okay. So, what is highly permeable? A drug substance is considered highly permeable when the extent of intestinal absorption is determined to be 85% or higher. When the permeation is 85% or more, we call it highly permeable. Now, you can see that BCS class 1, 2, 3, 4, the drugs, all kind of drugs can be classified into these 4 classes. Say for example, rofecoxib, paracetamol, propranolol, metoprolol are class 1, nimesulide, nifedipine are class 2 drugs, class 3 drugs acyclovir, atenolol, ranitidine, and among the class 4 cyclosporin A, furosemide, and so on. You can learn some more examples of each of the class. Okay, come back to us in the discussion forum. We can discuss the things also further. Now, how to apply this thing? How to apply the BCS? We use this BCS for correlating the in vitro dissolution profile with the in vivo bioavailability of drugs. For developing the in vitro dissolution specification, we use the biopharmaceutical classification system. For developing a strategy for improving the bioavailability of new chemical entity, we use the BCS. For predicting the drug bioavailability, whether it is solubility rate limited or permeability limited, we can come to know with the help of BCS only. So, this is the beauty of BCS, that each and every aspect of drug development we need to know about the BCS class of particular drug. Now, what is the final message? Dissolution is a quality control test which helps to predict the drug release, batch to batch consistency, in vivo performance, bioequivalence, and obviously is a regulatory requirement. Now, solubility, dissolution and permeability, these 3 things govern the absorption of a drug after oral ingestion. As far as the BCS is concerned, it is a drug development tool based on aqueous solubility and intestinal permeability of drugs, and it is called a 4-box model in which all the drugs are classified into 4 major classes. So, we will be live at discussion forum on Sunday, and the time will be notified later to you. So, next module we will be covering the polymerization, and that will be the last module of our pre-formulation. So, stay tuned for our next video.